Hello, my name is Hanna Grene, and I lead global go-to-market and operations for the energy industry team at Microsoft. I'm also a proud board member of Grid Forward, and I am delighted to be joined today by Grid Forward board chair and Utilidata CEO, Marissa Hummon, and global energy industry lead for NVIDIA, Marc Spieler. Marissa, Marc, it's a pleasure to have you both on the podcast.
Thank you so much.
I'd love to start by having you both briefly share your background and where you're focused today in your roles and in your companies at this really exciting moment of innovation and change. Marissa.
Thank you very much, Hannah. It's a pleasure to be here with you and with Marc. Very excited to talk to you guys both about AI and the grid. A little bit of background on Utilidata. So we've been around for about 10 years and started our career doing a form of AI that doesn't really get as flashy of attention as it does today. But we started with real-time machine learning of substation operations. And we did it in real time because we were sitting on top of SCADA. So we had access to that real-time data. But we also realized that if you could control the grid in real time, you got a lot of benefits out of making that grid more efficient. So on average, we could make a substation about 3 or 4% more efficient by operating it in real time. And over the last few years, we've been partnering with NVIDIA and with edge of grid companies to bring that same kind of real-time data analysis, machine learning, and operations to the edge of the grid. So I'm focused on that at Utilidata as our chief technology officer, and have been good friends with Marc for a number of years as we've been partnering with NVIDIA to bring their technology into that. So I'll pass it over to Marc.
Fantastic. Great to be here, Hannah. Thanks for having us. So I'm Marc Spieler. I lead our global energy team at NVIDIA. NVIDIA is an accelerated computing platform company, very deep in AI. And I joined about 5 years ago to help drive the go-to-market strategy around power and utilities, as well as our oil and gas side of the energy sector. AI is transforming most industries in the world, if not all. And the exciting thing for NVIDIA is we try to find really challenging problems and then create solution stacks with key partners and customers. And through this journey, we have been connected with Utilidata on the distributed edge, and obviously Microsoft is a very large partner of NVIDIA's. So we're excited to come together and help solve the problem that so many utilities and grid operators are experiencing today, and help bring AI to the forefront of that and solve problems in a very different way for this industry than what they've typically solved in the past.
Well, it is a delight to speak with you both, and I'm really excited for the conversation today because we're really going to focus on the potential for AI to support a more decarbonized, resilient, and secure energy grid. All things grid forward is deeply focused on as a community. And I'm personally excited for this discussion because Microsoft and NVIDIA are close partners, and Utilidata is a Microsoft and an NVIDIA partner. So we're really in this sea of excitement and opportunity together. And in full transparency, Microsoft is an investor in Utilidata through our Climate Innovation Fund. So thrilled to be speaking with two leaders at the edge of the grid and at the edge of the grid with AI. And so, Marc, coming back to you, what are you seeing today in ways that AI is enabling the grid?
So AI is enabling the grid in a few different ways. First of all, the ability to look at vast amount of data, both operational technology data, meter data, and sensor data coming from the grid, and to be able to make inferences on that in real-time decisions in a way that hasn't been possible in the past, where you've had to have either more human interaction or you just possibly couldn't keep up and be able to assess situations in real time has been tremendous. The work that we're doing with Utilidata specifically, and the ability to push distributed AI out to the far edge means real-time capabilities that didn't exist before. And what I would say is that, in the past, data is captured at the edge and brought back to a data center, either a substation or a data center, processed, and then you're given insights, right? And you're able to predict things and make decisions. But that latency sometimes is just too much, right? As we start to see issues with lines dropping or potentially power being available from local resources such as solar or EV batteries or battery walls. And all of a sudden now that capability to make those real-time decisions is changing the way in which utilities are going to work.
That's fantastic. And Marissa, as your team is out working with customers today, enabling these use cases, what are you seeing in the here and now for how AI is enabling the grid?
So as Marc mentioned, we are bringing that AI capability right to the edge of the grid where we make measurements. And so, the meter itself measures 32,000 times per second. So, we can resolve the full, sinusoidal waveform of voltage and current at every endpoint in the grid today. But the processors that we put in meters today throw out most of that information. We collect just enough information to bill the customer, and that's the piece of information that comes back from the edge of the grid. So what we are doing with AI today, I'm glad Marc mentioned the inference server, is bringing that computation to that really high resolution information that's available at the meter. So with the inference server in particular, we are doing a lot of forecasting and predictions, and that's from everything from when is the next voltage violation going to occur at this location? Do we see anomalies that are going to devolve into grid problems like faults or full blackouts? Are we going to be able to forecast when the next EV gets plugged in? And so in combination with those inference models, we also build models for event detection. We often build those in the cloud and ship the model itself to the edge of the grid, and then use that model to do things in real time. And so as Marc was saying, like bringing all of the data back, not only is it, from a latency perspective, it becomes less valuable because you're not quite as in real time, but it's a huge volume of data that you're never going to push back over Wi-Fi or LTE. We use those event detectors to figure out, when did an EV when did an EV plug in within less than a second, right? What's the status of the solar inverter in less than a second? And those bits of information that are coming out of these AI models are now actionable in real time, both at the edge of the grid, also back at a central system. But those would not be possible if we weren't bringing that level of computation and insight to the edge of the grid.
Thank you so much. That is such a fantastic picture that you've painted. And I want to spend another second here because we are also so excited about what we're seeing with AI and forecasting in particular. I think of AI and forecasting as sort of peanut butter and chocolate, great alone, better together. and it is a big unlock for the industry. And one of the things you've highlighted in the work that you're doing at Utilidata is the real time and the bringing those insights real time. When you are thinking about real time in your projects, what does that look like? What's the time period we're talking about?
So because we have that full AI platform at the edge of the grid, real time is less than a second. And it means that the applications that are able to make a decision are getting that information immediately because they're on the same chip. And then if you couple that with some sort of gateway that allows for control signals to leave the meter, now you're getting action also probably, within a second and a half or something like that. But real time for us does mean that seconds category. Not every location on the grid needs that today. However, as we push the capacity of the grid kind of up to its limits and maybe even beyond what we've calculated as the hosting capacity, the kind of passive hosting capacity of the past, you're going to need that, that real-time operations in order to get the most out of the built infrastructure that we have today.
Absolutely. You're unlocking efficiency even without net new assets through
Yes.
operating differently. That is really exciting. So anytime, all three of us have been through technology waves in this industry throughout our careers. And we know that anytime you're introducing net new technology, especially in the grid space, in the OT side, change is hard, and there are barriers to that change. And so I'd love to understand, from where you sit, Marissa, what's holding us back in the industry, and what do you see as some of the hurdles to making progress on grid use cases for AI?
So I do think there are more institutional people and process challenges than there are technology challenges. And I think I can't wait to hear from Marc, because I think he's actually seen this happen in industries besides energy. But I think in the utility industry in particular, one of the big problems we see is that the old planning processes, the way we used to, look at a load forecast or look at a demand forecast, add 3% a year, build out a substation, plan for that new load forecast, that those methods are not adequate to handle the pace of change and the rate of growth of the utility industry. And I think one of the big problems I see is that in the face of those changes, which could spur, innovation and adoption of new things, in some ways it forces us even into a more risk-averse position. And those barriers come from evaluating technologies and problems in little silos. So, we are used to solving a load growth problem with designing a new substation or, calculating the right capacity for this line, as opposed to approaching a load growth problem from what virtual power plant capabilities could I bring in? How can I better use my existing assets? How do I create coordination from the customer to the large scale power plants? How do I get the control room to think about these things differently? And those kinds of like new paradigms that are key to getting AI to be part of like the underlying way that utilities approach problem solving. They just require a level of coordination and comfort across a wider group of people than we've typically solved problems in the past for utilities. But
absolutely, I'm seeing that same framework play out as well in our work, and unlocking the real business value of AI really requires a cross-team evaluation, because you want to think about the process and the operation of where you're applying AI from end to end. That means you need to sort of step back and often work across the different business units to frame up the full business value of that investment and the impact that you can make. So I agree that thinking about it thinking about these problems, the solutions, and how you value them more holistically is definitely a hurdle, but an important one to address. Marc, from your point of view, what are the issues that we really need to address to make more progress, especially with AI value that it can bring to the grid?
Well, so while AI is not new, it's definitely the commercial validity of AI is new, right? And the fact that just in the last couple of years, right, I think AI has come onto the scene as a huge impact, right, with Gen AI and everything else, because it's now commercially viable, right, for most companies to leverage AI to solve problems that wouldn't have been available to them a few short years ago. And so I think the mindset of CIOs and CEOs is such that they're proceeding with caution at this point, because it's still a relatively new concept. They want humans in the loop, which is very understandable, and they're not ready to fully embrace all of the benefits that AI could provide today. I think there's a huge education campaign that has to occur both at the utility level as well as the regulatory commission level I think we see this in other industries, and other industries that are highly compensated for innovation through profitability and all that stuff are embracing these technologies much faster and are turning AI into significant cost reductions and profitability and other things. But this industry, and I would say IT is kind of the same, right? They're measured on do the lights stay on, right? And not necessarily dropping costs and everything else with potentially some downside, right? Nobody wants downside in electric distribution. That's just not going to be possible. But I think we're starting to see some of the most innovative utilities adopt this. I think the federal government has done a great job in providing grants and financial backing to companies that want to innovate and are willing to be early adopters or first movers to accelerate the testing and the piloting of these technologies, which I think is fantastic. But I think that continued education and more pilots are really what's going to drive this. And I think we're getting a lot of engagement from organizations like Grid Forward and EPRI and EEI and others who are basically coming together to basically do projects and research to quickly get these things rolled out, because to be honest, regulations in most areas are moving faster than innovation. And if we don't do something, we're just not going to meet our goals, right? That a lot of states and federal governments have rolled out. And so I think I think if we can tie the outcomes back to reaching those goals, I think the industry will move forward. But there's always going to be hesitancy.
Absolutely. And this goes beyond AI, traditional AI, as well as generative AI. But I observe that when we think about how the future of the grid needs to operate to become more resilient, to become more secure, to become more decarbonized, and to support the volume of resources that we're electrifying and plugging in and using for generation, if we reframe around what does that future look like and what do we need to get from here to there, it's so clear that digitization of the grid is part of that equation. And that means we need to stop thinking about stuff we do in grid operations and OT and then stuff that IT takes care of. And we need to reframe and start talking about digital infrastructure and how we go on that journey together across our organizations, if you're in a utility or with your partners and in your partner ecosystem. And I find that to be a very, really helpful reframe. If we sort of work back from the future, we're all trying to create together. But, thinking about how we get there, Marissa, what's working and what do you think we need to do to move ahead?
I think the most, I guess the biggest lesson I've learned over the last 20 years is that people get things done. I mean, you can have all the best technology in the world, but if you don't have people talking about it and coordinating and collaborating to actually get it into play, then it doesn't work. And so I guess that really comes down to partnerships. And so I'm gonna highlight partnerships with Microsoft and NVIDIA. And our most recent one is with Aclara, a meter company that is integrating the custom Orin Nano that Utilidata and NVIDIA are building together into that hardware. And the nature of those partnerships that make them highly functional and impactful is that we're all working toward the same mission, and we're all bringing something unique and complementary together, and getting comfortable with like sharing the pie. That's really important for the technology community to bring a successful solution to market. And then the other key partner is the utility themselves. And I think what Marc said about the DOE grants is really important. Those DOE grants, the first round in particular, set a really high bar for the level of innovation they were expecting out of those solutions that were gonna come to market under that grant. And I think that has really helped the utility get more comfortable taking a little bit of risk on a technology that they haven't done before or that nobody has done before, and experimenting. But those partnerships, they require, sitting next to one another and trying something new. Obviously, with any technology and AI in particular, you want to have some safeguards around that, and that's very reasonable. But there's really no replacement for getting out and trying things. And I think some of those enabling institutions like EPRI and EEI are also a really key part of that mix. But you can't, as a big company or a small company, you can't go it alone. You have to have partners from your customer, all the way through your ecosystem, in order to bring those new technologies into fruition.
That's a really helpful and fantastic perspective, and partnerships and aligned mission are so key to all of this work, and I think really key to the grid forward ethos as well. So it's very, very fitting to land that as our focus.
Costly distribution upgrades, frequent extreme weather events, demand surging from an onslaught of distributed energy resources adoption. Do these challenges sound familiar? If so, you need Virtual Peaker's cloud-based distributed energy platform. We're empowering modern utilities with the tools needed in the new energy landscape. The Virtual Peaker platform unifies all aspects of DER management, from DERMS to customer engagement and demand forecasting. Learn more at virtual-peaker.com.
So I want to move us into futurist territory and ask you to put on a future thinking perspective. And Marc, if you're going to project out, it's 2030, which, on the one hand is 6 years away. On the other hand, it's tomorrow in the energy sector. It's an IRP away. But in tech, and you and I are energy people at tech companies. In tech, that's a long time.
That's right.
And bridging those gaps as we do, I would love to hear your perspective. It's 2030. How is AI being applied to the energy industry, and what do you think we've learned and figured out together?
So by 2030, I anticipate that the grid will be software defined, right? And AI models will be everywhere, right? And everything will inference, so that data will be moved as much as necessary, but as little as possible. Right. And, Microsoft and NVIDIA, we know how this works, right? We're software defined companies, right? When you update, when you push out a Windows update or you push out a driver update, things run better. They get faster. Security patches, all of those things. Microsoft's been doing this for a long time, and NVIDIA does it as well. And through our software, we tend to have things operate better years after they've been deployed, right? And so I would say that the grid will become the same. I think those people who are playing on the grid and producing open platforms and software-defined platforms where we can get more third-party participants in the market because it's an open environment, where people will compete for better security, better algorithms, and all of that can be pushed out across the grid. We will have to do that, right? We have to reduce I think it will reduce the stranded assets in the field, will require less labor, and which will eventually reduce less truck rolls, which means less emissions, and all of those things, because the grid will become, as you pointed out, not just more digital, but more software defined. And it won't be based on firmware as much as software platforms and AI models. And I think that's the future, right? I think there's a lot of smart people that are looking to this. They're cautiously approaching it, but the electrification of the world, especially data centers, EVs, and even homes, right, are considerable changes that the world can't just have happen without changes to the grid. And so we either have to slow progress or accelerate technology. And I think the US, as well as Europe and others, will choose to accelerate technology, then slow progress.
I think that is a really hopeful vision, and it's getting a little techie. But when you say open platforms, that just makes my heart sing, because I very much share that ambition and that vision. I think we can all hope that we will learn and accelerate as an industry where people aren't making money holding back the data. Mm-hmm. That the providers and partners working with utilities, that we earn money by delivering value, and that utilities have much more connected data across their ecosystems, across their grid, across their platforms, that help them operate with excellence, rather than, the what I've seen historically is many CIO teams spend more time than I would hope for them integrating a lot of different tools instead of getting value from those tools. So I think we as partners to utilities, I hope we can share that ambition and drive that change, so we can all get back to focusing on better grid outcomes and less on stitching stuff that doesn't work well together. So I love that open platform, open data concept. We're very much on that journey too. Marissa, I would love to ask you for your view of the future, but I'd love to push it a little bit further. And I learn so much every time I get to talk from you. And so I'd love to hear your view of the future. It's 2035, so maybe 2 IRPs. Where do you think we are in the grid?
Well, I'm going to say I hope, because I don't actually have that that crystal ball that can predict the future. And I think this builds on Marc's vision. So if we have, to Hanna, to your point, if we have digitized and we have added the infrastructure that allows us to turn those data into information and into actions, then I think what's possible in 2035 is the thing that we've been kind of dancing around for the last decade, and that is, a truly dynamic, efficient asset utilization, free choice energy system that supports individuals making decisions about what they want to electrify and when, that gives them the right information at the right time, or even gives their devices the right information at the right time about how to make use of energy, or how to provide energy back to the grid in a dynamic manner. And that the grid itself has the right amount of sensing to provide that information. And so, I think what I'm trying to get at is that vision of the autonomous grid. But even though we've talked about it for a long time, I think we've been missing these key pieces of decision making and assurance that it's actually going to work. And so, I've started my career at the National Renewable Energy Laboratory and have hung out with the national labs for a long time, and we've done dozens of very controlled experiments of device coordination, of device control. I'm going to turn this EV charger on, and now I'm going to turn it off. But that very kind of piecemeal, little experiments, those are going to come together to be an actually functioning in real time dynamic grid, because we have that underlying technology, the communication, the signaling, and then the intelligence necessary to get devices to talk to one another. And that's not just my EV to my thermostat, but that's my the transformer that's closest to my house to the transformer that's next on the line to determine, okay, maybe I'll switch the phase for this location because they're gonna charge their 2 EVs at the same time. But I think that level of dynamics is possible, and I think it's going to save us a huge ton of money because we will not overbuild the infrastructure. The utilities I've talked to are, claim about a 30 to 40% asset utilization on the distribution system, which was built as a set and forget system, right? They build it once, they set up the substation, and then they're like, all right, I'll check on load growth in a couple of years, right? That system evolving to one that constantly adjusts to the dynamic behavior, that's the system that will be able to push that asset utilization to 50 or 60%. And it's going to allow us to spend money in the right areas in terms of electrifying and decarbonizing, and not spend money on things that we can just utilize better. So that's my vision of the future. Hope it's not too rosy.
These are exciting and inspiring visions from you both. And it makes me hopeful and happy that we have leaders like you, Marc, and like you, Marissa, working to create these opportunities and create this future. I know for many in the sector, there's a sense of, would you like some change with your change? And it can feel overwhelming. We're setting about to recreate our industry in a new image for the future. And now we're setting out to do that with a lot of new tools and new opportunities with AI. But it can feel overwhelming because we're asking people to change how they work, where they work, how they prioritize, and how we operate with these new paradigms. And so I would love, as we wrap up and bring this conversation to a close, I'd love to hear some little rapid fire thoughts from you both, Marc and then Marissa. How are you recommending that folks get started learning about AI? And if you have books, tools, podcasts, methods, whatever you're using or you're recommending your teams use, what would you share with people to help them get started, get learning, get comfortable?
So, there is so much out there on YouTube right now, right, about AI and what it is and how to leverage it. And I would say that anybody who doesn't fully understand how it can be used in a commercial setting or a business setting can just Google it and it will pull up lots of videos. I think the alternative is to go to OpenAI, right, and go to ChatGPT and ask it questions, right? I use ChatGPT all the time, right? And it's very different than a Google search, keyword search or things like that. You can ask it questions, you can have a conversation with it, and you can get, I think, fairly accurate understanding, especially at a high level, right, as to how people are using AI. And to me, that will really, that's probably the best way. Right. I really think that is a great way for people to understand it. And then if you have a specific question about industry or your specific job, I would check out either one of our websites, right, NVIDIA or Microsoft's websites, and look under the specific industry and AI use cases, and you're going to find a lot of information at those sites. And worst call, give one of us a call, and we'll help you find it from there.
Thank you, Marc. That's great, Marissa. Before I come to you, I'll just double down on the get your hands on it. I use Bing and test prompts in it all the time. We share prompts within my team. We have a pretty flowing Teams chat where we share prompts and stuff we find that works together, because tuning your prompts is pretty magic to get you the results that you want. But asking your friends, iterating it, trying new things every day is a really powerful way to scale, to run up that learning curve. I'll also add Copilot. Of course, that's a Microsoft product, but I got to say, it's changed the way I work. I had an early dog food version before we rolled it out fully commercially, and I came back from maternity leave, and Copilot summarized about 3,000 emails for me into bullet points and highlighted which ones I needed to read and talk about a great use case for AI. helping drive some equity in the workplace. It's a pretty powerful tool if you can get your hands on it. But Marissa, over to you. How are you encouraging folks to run up the learning curve?
I want to echo something you said, which is that you really do need to have that curiosity, that mindset that you do want to learn new things. There have not been a lot of other technologies I've come across that really demanded of me to like sit down and explore them and play around with them. The great thing is that with the tool sets that have kind of formed around generative AI, it is very easy to get your hands on it and to start experimenting. I will second Marc's plug that like just about anything you want to see done with generative AI, somebody's made a YouTube video. Sometimes the music's really bad, but the content is still useful. And then lastly, I think, as we transition from kind of our traditional tools to more AI-based tools, I think you don't expect yourself or your company or your product to do so like holistically overnight. It's in steps, and so you can start very naturally in your personal life with having the generative AI platform plan your weekend for you. Some people have been like, oh, I've got a birthday party to plan, and I've got these soccer games, and when do I do my grocery shopping, and it'll lay out a schedule for you. It's a fun little experiment to get used to the idea that something else might optimize a schedule. You can imagine then applying that to optimizing when should I charge my car. So playing around with some little things in your personal life can make it feel a little bit more accessible, and really inspire you to try things in a business setting in our electricity industry. So probably the most important thing is just to have an open mindset, to be ready to learn new skills and learn new ways of thinking about doing things.
Thank you both, Marissa and Marc. This was just a really fun conversation, and I think there's going to be real unlock as we get together in our different venues as a grid forward community, and we start to share how we're using AI across the different members of the organization. I think we're going to learn a lot, share a lot, and help each other move ahead more quickly. So thank you both for being here with us today, and great conversation to have with you both.
Thank you.
Thanks again to our season sponsor, Virtual Peaker. If you enjoy Grid Forward Chats, please follow us on your favorite podcast platform. Give us a like or a review, and tell your colleagues. You can listen to all episodes and learn more about our efforts to advance the grid at gridforward.org.